Hi guys, welcome to the Energy Lab. In this lab, we're going to be rolling a cart down a ramp, just like we did in the Velocity Lab. And we're going to be converting our potential gravitational energy into kinetic mechanical energy. However, some of the mechanical energy is going to be converted into heat and sound because of the friction of the wheels with the actual ramp. So the point of this lab is for you to determine how much of the energy is lost due to these conversions. So what you're trying to figure out is how much heat and sound is coming off of our cart. How much energy are we getting in the form of heat and sound? To do this, you're going to use the motion detector to get your maximum velocity of your cart as it rolls down. You're going to calculate the kinetic energy using that velocity. And you're also going to need the mass of the cart in order to get kinetic energy, because as I'm sure you remember, kinetic energy, the formula for kinetic energy is 1/2 the mass of the object, that's our cart, times the velocity of our object squared. So we have to get the velocity and we have to get the mass of our cart. Then we're also going to calculate the amount of potential energy that our cart has. And to do that, as I'm sure you remember, we're going to need, again, the mass of our cart. We're going to need g, that's the acceleration due to gravity, that's 9.8 meters per second squared. And we're going to need the height that we're dropping it from. And that's going to be the height of the ramp at 1.5 meters, which is around here. So those are the measurements we have to take. We have to find the mass of our cart, we have to find the velocity of our cart, and we have to find the height of our ramp. If you look at the lab sheets that I gave you, the paper lab sheets, after you look at the front sheet, the Energy Lab background sheet, you can see that the procedures start with setting up the track and the cart as we did for the Velocity Lab. In this particular lab, it's important that everybody have the same angle to their ramp, and to ensure that, what I want you to do is make sure that the top of the ramp is caught between the top of the counter, the black part, and the cabinet part. There's a little niche in there that you can stick it in, and if everybody uses that same niche, we should all be at the same angle with our ramps. So you're going to set it up like that, and then you need to find the exact height of your ramp at 1.5 meters. So I actually taped my meter stick just because I had to take a picture and it wouldn't balance without being taped, but you don't have to do that. Somebody's going to hold the meter stick up to the ramp at exactly the 1.5 meter mark, and I even drew in, you can see where I drew a little black line. That little black line is an extension of the line that's on the other side of the ramp. So I just took my marker and followed that line over the edge of the ramp. And then I did the same thing. I marked on the ruler where the top of that line meets the meter stick. I'm going to show it to you up close so you can read the measurement with me on the meter stick. We haven't spent too much time taking measurements together, so I think it's important that you pay attention to how you get this measurement and get it exactly. It's important that you measure out as many digits as you can with the meter stick, and the meter stick can measure out 2 decimal places. So you're going to have however many digits before your decimal place plus 2 decimal places in your final answer. When you measure the height of your ramp, you should get a number close to this, but it won't be exactly the same number. And that's just because of variations in the thickness of the wood and a couple other different factors. So here's what I got when I did this. Here's the mark on the ruler that I'm reading right there. And it fell exactly on the line that's halfway between 74 and 75 centimeters, which means that I have 74.5 centimeters of height, but I could actually read between centimeters. I can estimate how many millimeters I have of distance, but I know that since I'm exactly on the 5, that means there's no millimeters at all. But I need to put a 0 there because I actually measured that space. It may not work out this way for you. You may find that you're not exactly on 74.50. You might be on 74.51 or 73.49 or something like that. But whatever your measurement is, it needs to go out those 2 extra decimal places. Now this is in centimeters, but we need our height to be in meters. And that's because our energy formula calculates energy in joules, and in order to get joules, you have to start with meters. So we have to convert centimeters to meters. To do that, you just move your decimal place over 2. So this is 0.7450 meters. Again, that 0 is important. We're writing it there for a reason. It's showing us that we actually measured that space. Next, we need to get the mass of our Hall's carriage, of our blue cart. In order to do that, first you have to zero your balance. That's what a zeroed balance looks like. If your balance isn't zeroed, then you need to make sure that, first of all, that all of the little beige riders are all the way over to the left. You should make sure the pan of your balance is clean and dry. There's nothing sticking to it. And then if it's still not balanced exactly on the zero, you have to use the adjustment knob. Here's the good old adjustment knob. Whoa! I hate when I do that. There's the adjustment knob. Students are always asking me, do I turn it to the right? Do I turn it to the left? Do I turn it towards me? Do I turn it away from me? I don't know. You have to experiment and see what works. So just give it a little turn and see if you can get your balance to get back to zero. Sometimes the balances are a little bit sticky. They're old. They've been around for a long time. They're very, very expensive. They cost over $500 a piece. I can have them repaired, but if you're having a really hard time getting a particular balance to balance, rather than waste all of your lab time trying to get something to balance, just choose a different triple beam balance. A couple of things that could be affecting it: you could have your balance on a not flat surface. A lot of the times the desks in our rooms are a little bit slanted because the floor is a little bit sloped. So you might want to move your balance to an area of the room like a side counter. Or, it could be that somebody's leaning against it, or that there's something stuck in one of the, like under here in the pan or something like that. But just do the best that you can to try and balance things. Make sure you're zeroed before you put something on the pan. The other thing to watch out for is to make sure that you have your card attached, right? Because you need that white card for the motion detector. And this particular white card is a little too leaning. It's leaning a little bit too much. We want it to be nice and straight and firm. But regardless, you want to make sure the card is already taped to your cart before you start massing it, because that will change your results if you don't do that beforehand. So then after you put it on the balance, you're going to read your balance. A lot of students have trouble reading the scale of a balance. Once you get it back to zero, you have to figure out, well, how many grams is this thing, right? So you start by reading the largest number. So I have the 100-gram rider is in the 100-gram slot. So I know I have at least 100 grams of mass. Then you go and you look to see how many tens of grams do I have. Well, I don't have anything in the tens place, but I do have at least 2 grams of mass in the ones place. So I know that I have 102 grams and a little bit more than that, right? Because the rider is between the 2 and the 3. And if I were to count the little black lines here, let me see if I can get a different color so you can see it. If I were to count the little black lines here, I can see that I'm between the third and fourth line. That's where that is, between the third and fourth little line. So that means that I have 102.3, and now what I have to do is figure out how far between the third and the fourth line am I. And I'm estimating that I'm about 2/10 of the way between the third and fourth line. Your measurement of your cart needs to go out 2 decimal places. So you should have this many digits in your answer. Your cart's going to weigh around 100 or so grams. Could be a little bit less, could be a little bit more, depending on, which particular version of this cart you're using and which kind of index card you have and how much tape you needed to tape it on, etc. But it should be around this mass. But more importantly, you need to make sure you have at least 2 decimal places after the digit. If it falls exactly on a line, that 2, for example, if it wasn't between these 2 lines, if it was exactly on this line to the left, well, then I would make that 2 a 0, but you have to write that 0 because you measured it. And once again, we're using the energy formula, which requires that our mass be in kilograms. So we have to convert grams to kilograms. And to do that, we're going to divide by 1,000. We're going to move our decimal 1, 2, 3 places over. So this is my mass of my cart in kilograms. And it really is going to be that long of a number. Okay, so now that you have the height of your ramp, the mass of your cart, it's time to get the velocity of the cart as it rolls down from the 1.5 meter mark. Now, you know how these motion detectors are. You're going to need to do more than one reading of your velocity. And if you look at your procedures sheet, you'll see that you have 6 trials, spaces for 6 trials. You only need to do 3 if the first 3 you do are within 0.30 meters per second of each other, just like in the velocity lab. That's the range of precision that is acceptable. So you need 3 trials that are no further apart than 0.30. and then you can get an average. Hopefully it won't take you more than 6 trials, but if it does, you can add the extra trials down at the bottom of the page. You just need to get one average velocity, and that's the velocity you're going to use for all of your calculations. The rest of the lab sheet is just asking you to calculate all of the information about this particular lab. So you're going to find KE, kinetic energy. You're going to take 1/2 of the mass of your cart multiplied by the velocity that your cart reached squared. That'll give you your kinetic energy. There's a box on the lab sheet where you have to write all of the work. That includes writing this formula, writing in the numbers that you're going to substitute in. So you have to fill in whatever your mass is. You're going to put that in here. Whatever your velocity is, you're going to put it in here. Then you're going to write your calculator answer here with all of the digits. Then you're going to write your rounded answer, keeping in mind that your rounded answer can't have any more digits in it than the least of your starting numbers. And then you're going to add your units. And that'll be your final answer for your kinetic energy. Then you're going to do the same thing for potential energy. The formulas are written right on the sheet. Remember that for potential energy, you're going to take the mass of your cart, multiply it times g. G is 9.8 meters per second squared. That's a constant. And the height of your ramp. Again, after you write out all of the steps, just like you did for KE, when you get to the end, you want to make sure that you're rounding to the right number of digits based on how many digits were in your starting numbers. Keep in mind that you only have 2 digits in 9.8, but that's not a measured number, so you don't count that one. So you only worry about your mass and your height when you're figuring out what to round your potential energy to, because that 9.8 meters per second squared is a constant. It's not a measured number. Finally, once you have your KE and your PE, the two numbers should be equal to each other because all the potential energy that you started with should turn into kinetic energy. However, they won't be equal to each other because some of the energy is going to be lost as heat and sound. So the difference between your two numbers is going to be your sound and heat energy. And there's a formula for that. And again, you have to show all your work. And it's listed for you right on the lab sheets what the formula is. It says PE, potential energy, minus the heat and the sound is going to equal the kinetic energy. So you're going to plug this into your formula and this in, and then you'll figure out what this number must have been in order to get them. Then the last bit of the lab is just answering some summary questions. Don't skimp on the summary questions. The summary questions are important. There are some words that are bolded for you to highlight what's important. The first question asks you what happens if you double the height of your ramp. You need to think about that. You should probably write out in the equation what happens. That's probably the best way to answer that question, is to do it mathematically. The second question asks you to describe one design change you could make. And by describe, you're just telling me this is what I would do. But then in number 3, it asks you to explain why that design change will work. So make sure you separate that into 2 and 3. And then question 4 asks you to draw the design change that you came up with. Make sure before you begin answering these questions that you look at the rubric to make certain that you understand what it is you are being held responsible for. The biggest problem I've seen with your lab so far, guys, has been people not looking at that rubric before they turn it in. Really look at it and make sure you understand what you have to include. Don't leave anything out. Make sure you show all your work for your calculations. Make sure that you give supporting details to the 4 summary questions. Don't be vague. You guys sometimes are really vague. You just sort of throw down an idea and hope that that's close enough. You got to be specific if you want to get the points. Make sure that you accurately measured the mass of the cart and the height of the ramp. I can tell if your numbers are way, way off. And make sure that you format your final document attractively. That's going to be really easy to do this time because I'm giving it to you on plain old paper. So formatting just comes down to having decent handwriting and making sure that it's nice and neat when you turn it in. If your rough draft doesn't look neat enough, I can always give you a second copy to complete the lab. Okay guys, have fun doing the lab, and I will see you when I get back.